Next, usually each day when you come in, there'll be papers laying up here on one of these tables. Those are your notes for the day. Come up here. There's two stacks. Grab one from each stack. By the time you get back to your desk, I will have it pulled up here, and we will start going over it. Shove your way in there and you tell them all to get out of your way because you're more important than them. They didn't do that? They include your dad. Did I have him in school? No, I just I couldn't pick him out so hard enough. Molly, I was going to ask you, is that a twin?
No, but his brother's all.
He's got brothers too. Probably, so, Sue, do you know Sue? Well, I don't know, she goes by something else now. Can't remember what I always call her Sue. Yeah, you can put your laptops up, sorry. Alright, what we're going to cover today, points, lines, and planes. Usually this is the way the notes will be. It'll be stuff that you have to fill in and just listen to some of it, and we'll go over stuff. We'll do some examples in the middle sometimes and other things. Be able to name geometric figures. When you're naming geometric figures, you got to make sure that you're naming them correctly. And there's symbols and everything that you have to use, and that's a big part of geometry. Model real life using geometry, we're going to do that throughout the entire year. Understand undefined terms. These three terms right here, you might want to draw something there on your paper. Undefined terms are those three. Those three terms are the basis of all geometry, and they're undefined. What's undefined mean? This is going to be one of those classes where I have to call on people all the time, isn't it? Come on, just answer so I don't have to call on people. I hate doing that. What's undefined mean?
Something that's not defined.
Not defined. Doesn't have a definition. So, I need a volunteer. Go ahead, Luke, come up here. Luke's going to take one of these pins up here, and he's going to draw a point. Luke, is it going to matter to you if I try to make you look silly?
No.
All right.
Just draw a point.
Draw a point. Letter L for Luke. Just put a big L somewhere close to it. Don't have to be quite that big. So that's Luke's point. Did Luke actually draw a point? Why not? Do you have to have a line to have a point? But watch. Is everybody watching? Did I draw a point inside Luke's point? So did Luke draw a point? How many points did Luke actually draw?
A
bunch. Give me a math term that means a bunch. Starts with an I. An infinite number. Luke drew an infinite number of points there. When I drew my point, now Luke's looking at me like, what? When I drew my point, did I just draw one point? No. Could somebody else come up here and put a little point inside my point? Is there any possible way that we could ever actually draw a point? So you're trying to pick out some exact point in space. Is there any way we can actually get down to that exact point? Because no matter what, no matter how small you make it, are there going to be other things that are smaller inside of it? That's why a point, you guys have a good laugh at that too when I start writing with the pen and I stand up here and poke the board. It doesn't do anything. I gotta do it. A point is undefined because you can never, ever, ever actually draw a point. Now, with what Luke did, he made a point, and that's what we have to do so that we can have points like in our book or on our paper or whatever. We have to say, okay, this isn't a point, but we're going to use it to represent a thing. Now, if I do this, if I make my point right here, how many lines in our world that connect my point to Luke's point? One. Exactly one. The other thing I'll say, don't tell me my line's crooked. There's no such thing as a crooked line. All lines must be straight. Don't ever, ever put those two words together. Straight line, all lines are straight. That's not a line. It's not a curvy line. It's not a wavy line. There's no such thing. All lines are straight. So I got Luke's point here. Sorry, Luke, I'm going to make your L smaller because it's getting on my nerves. So I got Luke's point there, point L, my point there, E. There's only one line in our world that connects those 2 points, and it's that line right there that we have. Now, did I actually draw a line? What do you know about a line?
It's undefined.
That's true. Give me a little more. Because you really don't know that yet, because I haven't taught it to you, but it's good that you're jumping ahead. What's true about every line? Straight. That's one of the things. What else?
It doesn't have any point
It keeps doing what?
going.
So, did I draw a line?
Yeah, no.
Why not? Because I stopped. If I'd drawn a line, what would I still be doing right now instead of talking to you? I'd still be drawing. That's why a line is undefined. You can't really draw a line, but we're going to use something like this to represent a line. Okay? A plane. Anybody have a guess what a plane is? Don't say something that flies. Heard that too many times. Plane's a flat two-dimensional surface. All right? It's two-dimensional. So this piece of paper, is it really a plane? No, because does it have a thickness? Yeah. Can I show you something that doesn't have a thickness? No, it doesn't work. That's why a plane's undefined. All right? Because I can't really show you a plane, but we're going to use something like this to represent a plane. Now with a plane, sort of like a line, does this plane just stop right here? What's it do? What's it do on this end? How about this end? Plane goes on in all 4 directions forever and ever. Give me something in our room that we'd use to represent a plane. The floor. That's probably the one I'll use the most. Give me something else. Ceiling, walls, your desktop, piece of paper on your desk. Give me something I might use to represent a point. Easiest one is you. You're a point. All right, so Molly's this point right here, point, point, point. All of you are in what plane? The floor plane, right? You're all standing on the floor right now, or sitting or whatever. So that's your plane. all of these students right here are all on the same what? Line. All right, and we're gonna learn what that is here in a minute. Are there other lines that would contain all four of these? And there's a plane that's the floor that contains all of them. Is there any other plane that would contain all four of these people? Here's where you got to use your imagination a little bit. Heavenly, you got any imagination? No? Is there some plane that goes in our world that runs something like this that would contain all four of those people? About some plane that looks like this, coming down this way, that would contain all four of them? If I could keep my plane straight. All right? So points, lines, and planes. I didn't do it that time. Undefined terms. Axioms, we're going to talk about axioms here in a second. An axiom is a rule. And we're also going to talk about postulates, theorems, corollaries. One of those you probably know at least one theorem that you've heard of before, and what's that? Pythagorean's theorem. And we're also going to learn about synthetic and analytic geometry. We'll talk about that, fill in what you need to fill in on this slide. It should be on the notes there. Fill in what you need to fill in, and we'll go over some of it. Reason a lot of people don't like geometry. It deals all with axiomatic systems. An axiomatic system is just something where you're given a bunch of rules and you start from one thing and using those rules get to something else, get to some conclusion. Well, that usually means that you got to put some thought and use your brain a little bit. Algebra is usually a lot easier, not for everybody, but algebra is usually a lot easier. That's why it comes first, because you get taught how to do a process, and you do that process over and over again. Then you add something else to it, something else to it. Geometry is not that way. You got to think things through logically. And we all know that when you say logic and teenagers, do the two usually go together? I'm sure your parents probably tell you that all the time. Do you think logically a lot of the times? You do, Luke, or Logan? When I call your houses and I ask your parents, is that what they're going to tell me? Oh, they think logically all the time. Definition, hopefully you know what a definition is. That's nothing hard. Axiom and postulate, I want you to write one other word in here. I'll probably spell it wrong. I don't really care. I'm not going to grade you on your spelling, so don't worry about my spelling too much. A corollary. Those three, we're going to deal with them like they're all one thing. And I'll probably say postulate more than I say the other two. So most of them, if you see an axiom and I call it a postulate, doesn't matter. They're all the same to us. A postulate is a statement that is accepted to be true without any proof. So it's just something that we take for granted is true. I think of a postulate or an axiom or a corollary like my mom telling me something. Because when my mom told me something, when she told me something, and I gave her that three-letter word that she didn't like, why would she tell me? Exactly. Say it louder.
Because I said so.
Because I said so. That's how she'd say it. Because I said so. Right? You know, I'm sure most of you probably heard that, right? So, that's what a postulate is, or an axiom or a corollary. Something we just take for granted is true. Don't ask why, it just is. Back in kindergarten or before you went to kindergarten and stuff, they told you that that was a what? A 2. Why? Good answer. Why is that a 2? Because they told you. For no other reason. Could they have told you that was a 2? Yeah. Didn't matter, they just gave you some symbol that stood for a 2. That's sort of like a postulate. It's something you just look at it and say, well, that's what I voted in, that's just the way it is. A theorem. Theorem's a little different. When Pythagoras made up his theorem, he had to prove it. Alright, so he had to prove all that was true. Then it became a theorem. So postulates, axioms, corollaries, something we just take to be true. Theorem has to be proven true. All of this stuff that we're talking about and everything in geometry is just like you're playing a game. You're given certain information and you're reaching some conclusion from that information. So if I did this, what shape do I have? Circle. What makes up that circle? A bunch of points. What's that in the circle? What's that called?
Radius.
Everybody know that? From the center to the edge of a circle is a radius. Alright? If I tell you that radius right there is 10 centimeters long, then I draw another radius over here. What can you tell me about that radius? 10 centimeters long. And we're going to have a rule later on in the year that's going to tell us that this radius and this radius are always the same. Alright? All we're doing is using an axiomatic system to get to that. We knew first we started with points, undefined terms. We knew that these points made up a circle. We knew that this was a radius, that's a radius. And then we're going to have a rule that tells us, hey, if that's a radius, then they both have to be the same, so that has to be 10 centimeters. We're just using one thing we know to get to the next, to get to the next, to get to the next, until we get to a final conclusion that we're trying to get to. That's all geometry is. Fill in what you need to fill in here. This is exactly what I just explained. We're going to use all of this stuff to get to a conclusion. I'll be out of the way in 1 second. We're using stuff to get to some kind of conclusion, some kind of logical conclusion. Colton here could get to a conclusion just by saying it's a fish. Well, yeah, that's a conclusion, but it doesn't have anything to do with what we were doing. Well, we're on undefined terms again.
Something that's undefined, that's not defined.
What are they? There's 3 of them. Lines, points, planes. Points, lines, and planes. We're going to have a whole bunch of definitions, whole bunch of axioms or postulates or corollaries, whatever you want to call them, throughout the year. Whole bunch of theorems, and we're going to use those rules to draw conclusions. You've already done this some. If I tell you that that shape's a rectangle, tell me something you know about it.
4 sides.
It's got 4 sides. You know that because at some point you learned, hey, if they tell me it's a rectangle, I know it's got 4 sides. Could be something else.
2 sides are longer than the other 2.
Maybe, not necessarily, not always. What kind of rectangle do you have where 2 sides aren't longer than the other 2?
Squares.
Squares. All squares are rectangles, but are all rectangle squares. Give me something else you do know about the sides of it. What do you know about this side and this side? They're always equal to each other. They're always the same. That's a rule. So if I told you this was 5 centimeters, how long would that one be? So you use that rule to get to a conclusion. What do you know about this angle right here? 90 degrees, it's a right angle. All rules that you learned that help you to draw conclusions about whatever it is you're dealing with. All right, set your notes off to the side for a second. Open up your textbooks, page 4. Page 4. Help them out, Jackson. 4 comes after what? And before 5. If I get that, Jackson will help me out. At the top of page 4, there's a paragraph up there. Read that paragraph. Then down below, there's a blue rectangle like down there where it's got 6 empty boxes. Read that paragraph, and then you're going to fill in those 6 boxes. I'll give you a hint to help you out. The first answer is gourd. You don't believe that, Jackson?
No, I believe it.
Shouldn't. Is there a gourd that's an animal there?
No, sir.
No, I'm just catching on.
Was it hard breathing? It wasn't? Because you got a giant brain, is that why? All right, mammal that lives in the mountains or born in the mountains or whatever it says. Rorks, everybody agree with that?
Yeah.
About a mammal that was born in the valley. Whatever you said, is that right?
Yeah.
How about the birds? Mountains.
Packs.
Packs, is that what it is? And valley.
Red.
And the reptile mountain.
Englewood.
Yeah, whatever you said. And the valley. So, everybody agree with all those? All you're doing there, an axiomatic system. They gave you a set of rules up there in that paragraph, and you followed those rules to come up with your conclusions down there in the boxes. All right? Set your book off to the side for a second. Pull the notes back out. Fill in what you need to fill in on this. Should be on the back side of your first page of notes, right? Very top. Many different types of geometry. We're probably going to talk about these two here at the start of the year, and probably not worry about it after that. I really don't care that you can say what type of geometry you're doing. I just want you to be able to do the geometry. And be able to do the work. Synthetic geometry is just the study of geometric figures. So, you're looking at a shape like we were doing a second ago when I drew that rectangle on the board. We were doing synthetic geometry, which is also called Euclidean geometry, pure geometry, so on and so on. All kinds of different geometries. Analytic geometry, study of geometry. Don't make fun of my typing skills here. I didn't put a space between study and did I? Using a coordinate system. Does anybody know what a coordinate system is?
Coordinate plane,
Coordinate plane. What is that? Explain it to me. Anybody?
or quadrants, or it's on the grid.
So you might want to do this next to this. If you see something and it's on this where you got your x-axis and your y-axis, that's analytic geometry. It's that simple. If you see something that's on a grid, it's analytic geometry. If it's not on the grid, synthetic geometry. Set your notes off to the side, open your books back up. Drive me nuts, isn't it, taking on jumping back and forth. Open your books up to page 6. There, Logan, you can make fun of me. I forgot what came after 5. 6, thank you. On page 6, looking at the very first one at the very top there, using analytic or synthetic geometry. Synthetic, so put an S in the blank down there below it. Finish out the page. You can just put S's or A's in the blank so you don't have to write a whole lot. How do you know if it's analytic geometry? If it's on a coordinate plane. Synthetic, if it's not. Kylie, too difficult? Everybody think they can handle that? Don't need to go through those answers, do we? Ignore that. Back to your notes. Just drop this in. Fill in what you need to fill in on this. We're going to rush from here on out because we're getting this done. I don't care what it takes, we're getting it done. A point. When you name a point, point doesn't have a symbol. Most things that we deal with will have symbols, and we'll use the symbols to name them. Point does not have a symbol. So when Luke, sorry, I had to think about who I asked to come up here. When Luke went up there and drew his point, how would he have to name it? Point, writing out the word point, and then what?
L.
the letter L, the capital L, that's it. Point, capital L. It's always gotta be an uppercase letter, big letter. No little case letters, all right? Some of the stuff will have lowercase letters, points do not. So point A, point L, point E, whatever, but you gotta write it out, it doesn't have a symbol. No symbol for a point. A line, a little tougher on the line, I'll give you a second, fill in what you need to fill in on that. This is one of them that a lot of people mess up all the time. So if you listening closely here, should be pretty easy, but somebody name our line up here for us. Somebody name this. How many letters to name a line? Two, always two. So you pick two letters that are on that line. So L-E. If I just write this, what's gonna happen when we take that first test? It's wrong. How come?
Line,
You got to have that symbol. Symbol goes above it, two capital letters, every single time. What's another way this line could be named? Does it matter which order we go in? No. Put this on here. Point A is on that line somewhere. Now name it a different way. Now, when you named line AE and line LE, did you name the same line? Yeah, because if I trace AE, that's this line, right? Keeps going in both directions forever and ever. If I trace LE, did I trace the same line? Yeah, with a line, it doesn't matter which two letters you pick. So it's two letters, two uppercase letters with the symbol above it. Not three letters, not one letter, not four letters. Two letters, every single time, two letters. The other way you can name it, I don't like this way, but a lot of like the EOC test and different things in your book use this way because it's easier for them to put it on a piece of paper, is they'll put a lowercase letter out here beside the arrow. And that letter doesn't correspond to any point, it's just some random letter that's out there at the end. Well, if you have that random letter, you can name it, you can't use the symbol, but you can name it with the word line and then that lowercase letter. So different ways to name a line. Again, I don't like this way because it's more writing for me. 1, 2, 3, 4, 5 letters. Where here I want to write two letters in that one symbol. I think this way is easier. That way is just easier to put it on a piece of paper or something. I draw this point. That's my point, point E. How many lines through that one point in our world? How many lines could there be through that point? Let's go that route. Infinite number? So tell me to stop drawing when I've gotten every one. What's going to happen?
It's gonna go like a circle.
Am I ever going to get every one of them? No. Matter of fact, once I get done, and this is so clogged up that I can't see anything, is there a line that comes through the board like this and goes to that point? Is there some other line that comes from here and goes to that point? So what are you going to write here? Infinite number. There's an infinite number of lines. Oh, the other thing too, every now and then my pen will, it's the first time it's done it this year, it'll just go crazy and make some random mark flying around the board. Just ignore it. I got 2 points. Got Luke's point here again and my point. We already said this. How many lines are there contain those 2 points? Exactly 1. And I think that's might be what's on the next slide. 2 points make exactly 1 line, so no matter what, you're given 2 points anywhere in this world. If I could hit it. Supposed to hit that G there and I missed it. You're given 2 points. How many lines connect those 2 points? So I got my point right here. Custodians love me because I draw on my walls and stuff. I got this point right here, and then there's some point over in New Paris. How many lines connect those 2 points? Exactly 1. What's the root word of this collinear here? Root word. What is it? Say it louder. It's just line, right? What's co mean?
2,
Maybe. Multiple. They share, right? So what's collinear mean? They share a what? So when I draw this line, forget that, don't need that. When I draw this line in here through those 2 points, we know that point R and point G are collinear. They're on the same line. That's all collinear means, on the same line. What points are collinear in this picture over here? L, A, and E, they're all collinear, aren't they? What do you think this means? Non-collinear. Not
On the same one.
on the same line. All right? What do I know about all these students right here?
Earlier.
They're collinear. What do I know about these 2 students and this student?
No.
They're non-collinear. What do you think coplanar means? We can get to that here in a second. On the same plane. What do you think non-coplanar means? Not on the same plane. So Liam, you wishing you were back in algebra yet? Alright. When you're naming a plane, that says you gotta pick 3 non-collinear points to name a plane. So it's always 3 letters to name a plane, but they gotta be non-collinear, not on the same line. The reason for that. I got these 3 students right here. Are they all on this plane? Yeah. Now, if I name my plane using those 3, do I know which plane I'm talking about? Am I talking about just the floor? Here's where you gotta be able to use your imagination, sorry. Is there some plane in our world that comes down through here like this that would contain those 3 students? So are they only on this plane that's our floor? No, there's other planes that they would be contained in. So if I pick, again, if I go back to these 3 students, they're all on that plane, the floor. Is there any other plane in our world that would contain all 3 of them? No, because you can't bend the plane around to make it fit what you want. Okay? So that's why we gotta pick 3 non-collinear. We can't pick 3 on the same line. So when we're naming this plane, you're gonna name it plane. There is no symbol for a plane. Use the word plane. Pick me 3 letters. Could also be named plane. Pick me 3 letters.
ELT.
Is there many ways to name that plane? So when we're taking a test and I say, name a plane, are every single one of you gonna have the same answer? No. So I'm gonna have to know all the possible answers. What's your question? Come on, you're gonna ask something. Tell me how I could not name this plane using 3 letters.
BLA,
BLA, how come?
because they're on the same line.
They're all on the same line. I wouldn't know if it's this blue plane here, if it's some other plane coming through here like this. All right, another way that you can name a plane, if they give it to you, and this way is easier, if they give you some letter that's not corresponding to some point in one of the corners, then you can name it just using that letter. So this might be plane P. 2 different ways to name a plane, either with 3 letters or with that one letter that's in the corner all by itself that doesn't represent a point. What do you think non-collinear means? We didn't say that one yet. Non-coplanar, or yeah, we did say non-collinear, didn't we? What do you think non-coplanar means? Did we ever say that? Yes, no, maybe? What's collinear mean again?
Terminal points on the same line.
Same line. What's coplanar mean? Same,
So they're not on the same plane.
no, coplanar.
Oh, they're on the same.
Same plane. What's non-collinear mean? Not on the same line, non-coplanar, not on the same plane. Space. We won't deal with space. I'll see if it's on there and fill it in. Space is everything. All right, we're not going to deal with that a whole lot because in the book, when they ask you a question, how are they going to be able to show you space? They going to be able to do it? No. Intersection. If I have 2 lines here, 2 lines intersect, how? Out of what? What's that called right there? Point. 2 lines always intersect at a point. Now a little harder one. I can't draw it, and I'm not even gonna try because I'm not an artist. 2 planes. What do 2 planes intersect at? Think about, you guys told me earlier, this wall's a plane, right? This wall's a plane. What do they intersect at? A line. Right? So 2 lines intersect at a point. 2 planes intersect at a line. I think that might be the next thing, isn't it? 2 lines intersect at a point. 2 planes intersect at a, ignore that. Can everybody read that says line? Moving along. Non-collinear, what's non-collinear mean again? Not on the same line, you can fill that in if you want, not on same line. Now you gotta be careful. What's not on the same line? Points. There's nothing else on lines besides points. You can't say, this rectangle and this rectangle are non-collinear. Well, rectangles can't be on a line because they're rectangles. Alright? So it's gotta be points. What's non-coplanar mean? Not on the same plane. Again, with this, you gotta be careful. I picked Tayton, Isaac, and that circle thing up there is my 3 points. Are they coplanar?
No.
Is there some plane in our world that would contain those 3? Now, if I stick Logan in there, are they all coplanar? So you got to be careful, all right? How about if I pick 2 points? If I pick Kylie and I pick that's not right. Is it Reagan? I pick Kylie and I pick Reagan. Are they collinear? Is there some line that would connect them? Yeah. If I pick any two people, are they collinear? Yeah, because any 2 points make exactly one line. If I pick 3 points, are they always going to be collinear? No, that's when you got to start making the decision. A ray, oh, I'm sorry, the segment first. Segment, if I draw a line, a segment is exactly what it sounds like. It's a line segment, so it's just part of the line. Goes from here to there. What's different about a segment and a line? What can we do with a segment that we can't do with a line? Main thing that we're going to do a lot of. Can measure a segment. In our world, are segments more useful or lines more useful? Segments. We can actually do something. If you're building something, are you making it a line? No, you're making it a segment. Segment, we use 2 letters, and this is our segment symbol. Array starts at 1 and goes out in one direction forever and ever. And this is the ray symbol. Nothing really hard about any of those. Opposite rays form a straight angle. Does anybody have a guess what a straight angle is? How many degrees? 180 degrees, like half a turn. We're not gonna do that. Your assignment's on there.
I get this from there.
Your assignment's on there. It looks long. It's not really very difficult. Make sure you get a binder, calculator. Get everything started back.